So the purpose of this lesson is to go over some basic ideas related to measurement, the measurement chapter in the course that from early on in the year. I have a separate video if you want to see some more examples of Pythagorean theorem other than the ones that I'm going to present in this video. But you'll remember that essentially Pythagorean theorem relates to right angle triangles. So you can tell that it's a right angled triangle because of this little box. And the measure of a right angled triangle is exactly 90 degrees. Now you may also remember that the side of the triangle opposite the 90 degree angle, it has a special name. It's called the hypotenuse. And the hypotenuse is always the longest side in a right angled triangle. You'll also remember that the square of the two smaller sides, I'm not drawing perfect squares, but you get the idea. The sum of those is always equal to the square of the hypotenuse length. And that allows us to come up with this handy dandy formula that a squared plus b squared equals c squared. Again, if you need to see examples of this, please refer to the video that's linked into the Google Classroom post for this lesson. So here's one example from a past EQAO exam that I want to go over really quickly. So it says, use the Pythagorean theorem to find the length of the diagonal in the rectangle below. All right, so here clearly they've identified the diagonal, and they're telling me that it's a rectangle. And so rectangles by definition have to have corners that are 90 degrees. So this corner down here, I haven't drawn this perfectly, but you get the idea, has to be a 90 degree angle. And so really this side and this side represent the smaller sides of the triangle. And this diagonal here that I'm looking at is actually my hypotenuse. So that's like c squared in the formula c squared equals a squared plus b squared. So remember, my hypotenuse is always the longest side. And so right away I can get rid of at least one of the answers here, if not more. So I know that my sides are, my hypotenuse has to be the longest side. So there's no way that this length of the hypotenuse is 58. So I'm going to get rid of that. I'm also going to get rid of the 66 as well. The reason being, again, my hypotenuse has to be the longest side, and 66 is not longer than 80. So now I'm down to my last two choices, and this is where I'm going to need to pull out some math. So I know that c squared has to be equal to the squares of my other two sides. So whatever 80 squared is, and whatever 55 squared is. And so I'm going to go ahead and solve that. So I've gone ahead and done the calculations. So 80 squared plus 55 squared. So 80 squared is 6,400. 55 squared is 3,025. When I add those together, it gives me 9,423. But that doesn't give me the value of c. It gives me the value of c squared. So I'm going to take the square root of each side. And when I do that, I get 9,400 and something or other. The square root of that gives me a value that is closest to b, 97 centimeters. And so that is my answer. All right, so I want to look at a second example here. And in this case, same idea. They want to know it's two square gardens, and I want to know, have a welcome banner along this edge. So I know that I'm looking at a right angled triangle, right? And so in this case, instead, they're giving me the value of the area and of each of the gardens. So that actually makes it easier, because I know that there's almost like, if I could, I would draw out the third triangle that goes along with my hypotenuse, which is the banner length, right? So I could draw that out like that. And really, I know that this, which I'm going to call, c squared, that area, is equal to this square plus this square. So really, c squared is equal to 42, I've already done the squaring of that side because I have it in meters squared, plus the 36. And so c squared is going to be equal to the sum of these. So 36, 46, 56, 66, 76, 78 meters. Now, some of you may jump and say, oh, well, c squared, it's there, it's 78 meters. But remember, that's c squared. That is the area of that whole square. So in order to find out what the value is of the length, right here, not the whole area, I need to find out what the square root is of 78. And so I know that the square root of 78 is going to be closest to 9. If I punch in the square root of 78 on my calculator, the value that I get is closest to 9 meters, and so that will be my answer. That's it, folks. So I want to remind you that about perimeter. Perimeter, remember, is the distance around the outside of an object, right? So that's just measuring distances. It's a one-dimensional thing, and my units will not be square units. They won't be cubic units. They'll just be units straight up, right? So for instance, here I've got something that looks like an H, and so I can get the perimeter by just simply figuring out what all the distances are around the edge, outside edge, not the inside edge. So you go 4 plus 4 plus 5 plus this side right here, I can assume is also 4. So I have to make some assumptions. 3, and then since I know that this entire length is 12, this length right here would also be 12, and so on and so forth. So there's some filling in of blanks here that I might need to make, but essentially I just want to almost like trace around and find the distance around the outer edge here. All right, so here's some examples of questions. So it says, which dimensions produce the smallest perimeter for a rectangular area of 120 meters, right? And so to me, a strategy you could use would be to actually draw out boxes with this dimension and then figure out from there. So for example, I'm just going to do the first one here. So, I would have a box that is 2 by 60, right? So I know that, the 60 would be here and the 2 would be here. And perimeter is the distance around. So I know this other side would be 2 and this one would be 60. So overall, I'm looking at a perimeter that is 60 plus 60 plus 2 plus 2. And so I would write that out for myself. So 60 plus 60, 120, 122, 124. And then I might go through and I might see what the different ones that I get are. And so that would be my strategy for going about this. And I want to know the smallest perimeter. So when I'm done figuring out all these values, I would choose the answer with the smallest perimeter. And I may not even need to draw out all the boxes. So for instance, once I have this example, I can tell from the dimensions that all I'm going to have to do is, I'm going to have 2 sides that are 3 meters and the other 2 that are going to be 40. So 40 plus 40 is 80, 83, and then 86. So this is going to be 86. Okay, 30 plus 30 is 60, plus 4 is going to give me 68. So I can see how this is going. And then here I have 20 plus 20, and then 6 plus 6. So that's 40 plus 12, so that gives me 52. So I can see that D is going to be my answer in this case. There was a quicker way to do this though. If I notice from this example, I can see that the smallest perimeter is achieved with the rectangle that is the most square-like, right? So the one that is not the skinniest and longest, but the one that is most square-like. And so if you see other questions like that, that's a big way of helping to identify which is going to have the smallest perimeter. So let's look at this next example. So over here I can see that some students use 24 large square tiles. So I don't have any more, any less than 24 tiles. And I want to know which of the tiles are going to make a rectangular area with the smallest perimeter. So again, I can use a strategy similar to what I did over here by having 1 row of 24 tiles, 2 rows of 12, 3 rows of 8, or 4 rows of 6. So again, if I forget about what we just talked about, I can draw these out. So I can draw a row with 24 tiles all in a row. And if I look at that, well, if each tile is, has a certain width, and I'm going to have 24 of them, I would basically have a big long lineup of 24 tiles, which I'm not going to draw. But this one side would be 1, and the other side would have 24. And so I can quickly see how that's going to shape out compared to 4 rows with 6 tiles. Well, that is going to be the one that looks most square-like, right? The length and the width are the closest together. And so I would wager a bet that the answer to the smallest perimeter is in fact the one with the dimensions that are most square-like. You can go ahead and try that out yourself. You'll see that you'll end up with the same result, with the smallest perimeter being the one with that has a 4 by 6 area. So the next topic I want to talk about really briefly is area. And so area, you'll remember, is different than perimeter. We're not talking about the distance around. We're talking about all the space that fills it in, right? So in order to do that, I may need to break up some shapes into different pieces. So like for instance, I want to see how the easiest way to break up an object, and sometimes there's more than one way to do that. So for instance, in this H, I might break them up into individual triangles, or rectangles rather, and then find out the areas of the different spots, and at the end, just add them all together. So this might be area 1, and then area 2, and then area 3, and then the total area would be all of the areas added up together. Right? So notice in this case I have to find all the space in between. This second shape here, well, it looks like they've already sort of broken it up. So I'm going to have to use the formula for a rectangle and then use the area for a circle, but then find out what half of a circle would be. In this case, you'll notice that I have a square on the outside that I want to find, but I don't want to find the area of the whole square. I want to just find the area of the shaded portion. And so I would have to find out the area of these two little rectangles here by separating them, and then subtract that area from the whole square. So my biggest hint to you is to use your formula sheet to help you. I'm going to just switch to a document of that. You'll have this on your exam, so make use of it. Here's your grade 9 applied sheet. Make sure you read really carefully to see, are you looking at perimeter or looking at formulas for area? And they give you a whole bunch of different formulas to use. So like for instance, if I scroll down here, I have the area of a triangle, which you'll remember is a half base times height. I have the area of a circle, and it reminds you, well, what is a radius versus the diameter, and so on and so forth. So make use of those formulas. I'm going to talk about volume in a second here, but remember, you also have formulas for the volume of different geometric figures. Use them. Make use of those. So with that, so in this question, they're saying, consider the square below. What is the area of the shaded part, right? So before even doing any math, well, not any hard math using formulas, I can probably figure out the majority of this. So if you remember that, if this is a square and they're telling me it's a square, I know that if my length here is 6, and that means that this height here is also 6, right? So area of a square is going to be length times width. So I know that my total area of the whole thing, not just the shaded areas, is going to be 36 centimeters squared. So that tells me that I know that the shaded area can't be 36. I also know that half of this is, half of the shaded area, or half of the square rather, is half of 36. So in other words, this little part right here really represents half of the square, and half of 36 is just 18, right? So I know that 18 can't be the shaded area because the shaded area also includes this other little part right here. And so that tells me that the total shaded part has to be between 18 and 36, and therefore 9 is not my answer. B is my answer. Right? So there's a simple way to figure that out without actually figuring out the total area of the shaded portion. So now I want to look at the second example here. And I don't want to go through the solution with you, but I do want to talk strategy. So when I look at this problem, I can see that it says that Hannah is working on painting sealant on a driveway. She charges $7.50 a square meter. So for painting, we're looking at covering the surface here, and that means finding area. So I'm going to need to first, before I even figure out the answer, I'm going to need to first figure out what the area is of the big square and the small square. But notice that the question's not asking me for the total area. It's asking me for the cost, what she's going to charge, knowing that she charges the $7.50 per square meter. So my answer is going to come by taking the area of this whole thing and multiplying it by what she charges per square meter, and that will get me my answer. So by breaking up my rectangle into a couple different pieces, I'm able to get that area. So I know this is a 5 by 5 square, so that means the area here is going to be 25 square meters. And I was able to figure out that this little length right here had to be 2.5 meters as well, because if the whole length is 5 meters and this little part is 2.5 meters, then this has to be 2.5 meters. And I use the same strategy for knowing this little length right here for this rectangle by saying 9 meters is the whole length, and I'm going to subtract the 5 meters. The leftovers tell me 4. And so 4 times 2.5 gives me 10 meters, square meters. So in total, I have 35 square meters. And I'm going to multiply that by 7.5 or $7.50 to tell me what the cost is for the entire driveway. Okay, so my advice to you again for volume is to use the formula sheet. Remember that volume is the 3D space that an object takes up, right? So it's not a flat surface, it's all around. And so that means that I'm looking at cubic units. So another couple of pointers that I want to point out to you just by looking at this picture is, remember that if the diameter the whole way across is 10, then that means my radius is going to be half of that, or 5 centimeters, right? So 5 centimeters. In this case, it says a candle made of wax is in the shape of a cylinder, and I know my formula is pi r squared h, right? So my radius is what the r is in this formula, but they don't tell me my radius. My radius in this case is only going to be 3 centimeters long. So those are some things that in EQA questions are going to help me figure out which answer makes sense. So let's look at those possibilities here. So it says, which expression represents the volume of the sphere? So remember, I don't have the complete formula here. I can check on my grade 9 EQAO formula sheet, and here it is. 4/3 pi r squared, or 4 pi r cubed divided by 3. So let's take a look at that. So I can tell right away that in some of these questions, they've actually added in 10, which is not my radius, but my diameter. So I'm going to get rid of those as choices right away. And notice that they've also multiplied by 3 instead of cubing the answer. So I'm just going to go back here and look and make sure. And my formula, it has the radius cubed, not the radius multiplied by 3. And so without even doing any math here, I can tell that my correct answer is B. Now let's look at the cylinder question here. And so notice that they're giving me the formula. They want me to substitute in my radius, which was 3. So I would be finding my volume by calculating through by taking pi, which is essentially 3.14, multiplying the radius of 3, and then squaring that. And that is 9. So 3 squared is 9, times my height, which they tell me is 12. So on my calculator, I would type those numbers out, figure out which of these is the answer that makes sense, and then I'm good to go. And so using my calculator, my answer ends up being 339 cubic centimeters. So that's it for my warm-up to get you started. Now you have the rest of the period to work on your CCT for this section. So remember that the CCT is worth 2% of your final grade. So make sure that you complete it and get that handed in class and submitted by the end of the period. If not, you can come in at lunch hour and finish it up.